All right, in this video, we're going to be looking at part 2 of the mechanics of breathing, basically going into some factors that can affect the amount of energy that is required for breathing. And there are 3 of these. The first one is called airway resistance. And if you think of the respiratory system, or particularly the conducting part of the respiratory system, as this big tree, well, as that tree gets closer and closer to the lungs, the diameter of those tubes gets smaller and smaller. And so, what this can cause is it can cause there to be some resistance in those tubes because air, like all things, produces friction when it rubs across each other. And so, this can cause resistance in those airways. However, resistance in the airway is typically insignificant as long as there's nothing wrong, because the diameters of the first parts of the conducting zone, are just really big comparatively to the end, to the terminal bronchioles, and you can kind of see here. And so basically, there's a point at the medium-sized bronchi where the resistance is highest, and then as you go, those tubes are just too small for there to be any real resistance in those smaller tubes. The only way that resistance can come in is if there is some kind of blockage or some kind of restriction of those airways from maybe inflammation or something else that's going on. A second thing that can cause you to have to use more energy when you are breathing is something called alveolar surface tension. And this has to do with water. And so when we talk about water, the surface tension of water is basically the attraction of the water molecules to each other, particularly when it comes in contact with a gas. And so basically, the water will like itself more than it likes the gas. And so water, because water is polar, it has an extremely high surface tension when it comes up against a gas. And so you think of like the bugs that are able to sit on top of the surface of the water, because the water likes itself more than it likes the bug's feet. And so it allows a really light animal to kind of sit on top of the water. And so you can see here the water coats the inside of these alveoli. And so under normal circumstances, the surface tension of the water would be higher than the gas's ability to diffuse through it. And so it will resist the force of that gas to diffuse through the water. However, the alveoli are coated with something called surfactant, and you see that there on the right. And surfactant is like a detergent-like lipid and protein complex, and this helps to reduce the surface tension of this alveolar fluid, and this prevents several things, because what can happen with those alveolar surfaces is when the surface tension is too high, it can actually cause those alveoli to collapse, which would not be good. Basically causes them to kind of just disappear. And so this surfactant prevents the alveoli from collapsing, and it's produced by the alveoli cells themselves and allows the water to diffuse across, right? And so we do the same thing when we wash things. We use a detergent or we use soap, and the purpose of that is that it decreases the surface area of the water and allows the water to actually penetrate the things that we're washing. And so rather than the soap working itself, it actually lets the water work better, if that makes sense. And so it's the same sort of thing here. Water is the thing that helps the diffusion of the gas, and so the surfactant then allows water to do that better because it decreases its surface tension and allows you to be able to breathe. There are things that can go wrong that can cause this. We'll talk about that in a minute. And then the last thing that can require you to have more energy when you breathe is something called lung compliance. And lung compliance is, the simple definition of it is just the measure of change in lung volume that occurs when you breathe in, when you breathe out. The lung is typically very stretchy. And so if you want to think of it as your lungs' ability to stretch, that's another way of thinking about it. Normally, lung compliance is really high because the lung is a very distensible structure, very stretchy. Think of it as like a sponge, more so than like a bag. It's like a sponge that has all of this surface area, and it is able to expand and then go back to its original volume very easily. And the surfactant that we looked at in the last slide is also very important in this, because this decreases that alveolar surface tension and allows it to expand and return back to that original state. And so the higher the lung compliance, you can kind of see this on this picture here, the higher the lung compliance, the easier it is for you to expand your lungs, and therefore the easier it is for you to use your lungs. There are things that can change each of the three things that we talked about: airway resistance, alveolar surface tension, and lung compliance. And this typically has to do with diseases of the lungs that cause increased inflammation in the lungs. Chronic inflammation, any kind of infection like tuberculosis is what you see here. And what it does is and you can see this degradation of the lung tissue here from a relatively healthy lung that kind of has this one spot of tuberculosis. But what happens as tuberculosis works its way through is all of that white that you see there is scarring in the lung, and it loses its elasticity. And so then in order for you to breathe, you have to like use a whole lot more energy. It becomes less of a passive thing that you're doing and more of an active taking breath is kind of a tough thing. And so people who have had diseases like tuberculosis, this can cause serious issues. But there's also other things that can cause lung impairment, just something like smoking. Smoking is basically removes the surfactant from the alveolar surface tissue, and we'll talk about this in another video as well. But it causes problems inside the lungs, and you're not able to get in the breath that you should. And so as the lung compliance lowers, then it requires more and more energy to take a breath, and for that breath to be meaningful as far as the amount of oxygen that you're receiving.